It's great to have you back. Today I have another JEE problem from JEE Main 2016 and a really neat solution. Question number 9 of Code E Physics. N moles of an ideal gas undergoes a process A to B as shown in the figure. The maximum temperature of gas during the process will be. And then there is a graph. On the x-axis is V, volume, and y has P, pressure. Before I describe to you what the question is, let's understand what is an ideal gas. An ideal gas is one which has perfectly elastic collisions. And perfectly elastic collisions are collisions in which there is no loss of kinetic energy. Kinetic energy is half mv square. Now the question says that during the process there is a point at which the temperature is maximum, and we have to find that point. So how can we do it? Let's look at the graph. The point A can be written as V0, comma 2P0. Why? Because on the x-axis it cuts the x-axis or drops on the x-axis at V0, and similarly at 2P0 on the y-axis. Similarly, point B can be written as 2V0, comma P. That's the notation x, comma y, right? Now to solve this problem, we know that there are 2 points given. Let us assume that between A and B there is a point C, which I have shown in the graph. So this is the point C, and let's assume and let's call it, just as we call an unknown quantity as x, we will call this V, comma P. So let V, comma P be the point at which the temperature is maximum, and we can solve for this by using the property of line which is known as slope. The slope of line calculated by any 2 points, it doesn't matter which 2 points, will be the same. So what is the slope of a line? The slope of a line is defined as change in y over change in x. So we can say y minus y1 over x minus x1. Slope of a line is also defined as tan of theta, where theta is the angle the line makes with the x-axis, but we are not looking at tan theta right now. We'll use this formula. It's also a pretty well-known formula. Y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. And then let's substitute the points we have in places of y, y1, and x2, etc. So the points are, let me first consider points C and B. So y minus y1 would be P minus P0 over V minus 2V0, fairly easy, is equal to, let me now consider points A and B. That would be 2P0 minus P over V0 minus 2V0. I hope this is easy. And then I'm gonna send this denominator right here over to that side, other side, and let me then get P minus P0 is equal to this minus this over this multiplied by the denominator that was on the other side, V minus 2V0. Now what is 2P0 minus P0? It is P0, right? So I'm gonna take this expression and I'm gonna write P0 here. And then what is V0 minus 2V0? V0 minus 2V0 is negative V0. So I'm going to write V0, and then I'm going to take the negative sign over on the numerator side, right? So that is now minus P0 over V0 multiplied by V minus 2V0, and then I have taken this negative P0 on the other side to get plus P0. I hope that makes sense. Now I will then try to solve this further, and the way I'm going to do it is by multiplying this into this to get negative P0 V over V0, right, plus 2P0 V0 over V0, and then this V0 and this V0 can cancel out, plus P0. So finally I will get P is equal to negative P0 V over V0 plus 3P0. Now I have P. If I multiplied both sides by V, I can then use the formula PV is equal to nRT, so that I can then calculate for temperature. I'm supposed to calculate temperature. So using that intuition in mind, I'm going to multiply V on both the sides so that I can substitute PV is equal to nRT later, right? So PV is equal to negative P naught V squared. I have multiplied V over V naught plus 3 P naught V, right? So 3 P naught came from 2 P naught plus P naught. I got 3 P naught and then multiplied by V. Now I'm gonna substitute PV is equal to nRT. That's the ideal gas equation. And then nRT is equal to negative P naught V square over V naught plus 3 P naught V. Now, what's the next step? Now, I'm gonna keep T here because I'm supposed to solve for T. T is equal to 1 over nR multiplied by whatever expression I had previously, right? Now, at what point is temperature maximum? So if you see the temperature, if you had a graph with temperature here and volume here and you wanted to plot a graph, it says temperature does maxes out at some point. Let's say it maxes out at this point. What is the slope at this point? The slope at this point is the tangent line touching the curve only at one point, and that would come to 0 because tan of 0 is equal to 0, right? So the point at which the tangent or the slope is 0 is the point at which the temperature will be maximum. So to do that, to find the slope at this point, we can take differential, because what is differential? It is change in this T over change in V. So if I differentiate T right here with respect to V, I will get dt over dV, and dt over dV is also the slope, just as we saw in the formula in the beginning. Dt is similarly change in T, which is like T2 minus T1 over V2 minus V1, but over a very small range, but it doesn't matter because I said in the beginning we can take any 2 points on a line and we will get the same slope. So we will use that very principle and solve it for dt over dv. So I'm going to take differentials on both the side and I will get dt over dv is equal to d over dv 1 over nr, and then the expression I had. So what is dt over dv? Dt over dv at the maximum point, it will be 0 because dt over dv gives the slope of the function. So 0 is equal to d over dv 1 over nr, and then r will remain constant, so I can take that out. I'm not going to differentiate it. And then d over dv p naught v square over v naught, I'm differentiating with respect to v squared, and p naught and v naught are constant values. They're not going to change because they represent a point on the line, and that's not going to change. The only thing that's going to change is v square. We're trying to see at which v square the temperature is maximum, so we can consider various v's, right? So we're going to differentiate v square, and the differential of v square is just as in x to the power n is nx to the power n minus 1, right? Differential of x to the power 1 is n is this, so v square would be 2v to the power 2 minus 1. We will get 2v, and then the constants will be written as they had been. There is no change in the constant. I'm just going to send nr to the other side so that they can multiply with 0 and I can get 0, and that will simplify calculations. And what is the differential of 3p naught v? 3p naught v is just 3p naught because v to the power 1 is just 1. V to the power 1 minus 1. 1 into v to the power 1 minus 1 is v to the power 0, and that is just 1. So I can write 1 here, but doesn't make a difference, right? And then the next point is p naught v naught. I'm gonna send onto the left hand side to get this is equal to 3p naught, and then if I solve it further, cross multiply, I will get, I can cancel this out, and then I can get V is equal to 3 by 2 V naught. This is the condition for maximum temperature. So when the volume is 3 by 2 times V naught, right, then we can, V naught is given on the graph, V at this particular volume temperature is maximum. So what I'm gonna do is I'm gonna substitute this value in the equation above to get the maximum temperature. I solved for T, right? So I said I want to solve for T so that I can then find the maximum temperature. So this is the expression I'm concerned about. This will give me the maximum temperature. All I need to do is substitute this V for the value I just found out, and that will give me the maximum temperature expression. And hopefully that will match with one of the options. So T max will be 1 over nr negative P naught V naught multiplied by, I had V square, so I'm gonna square this expression to put it here. That will be 9 by 4 V naught square plus 3 P naught into, and then I had another V here, so I'm gonna write 3 by 2 V naught. If I solve it further, I will get 9 by 4 P naught V naught nr. If you don't get it, let me solve it for you, right? So this is negative, this V naught and this V naught will cancel out. I will get negative 9 P naught over 4 plus 9 P naught V naught. Actually this is also V naught, negative P naught V naught over 2, and then I can take LCM, make this 4, make this 18. 18 minus 9 is 9, so I'll get 1 over nr multiplied by positive 9 over 4 V naught, and that is same as this, and this is option number 1, right? So option number 1 is your correct option. I hope you like the solution. I'm not 100% well today, so my voice may sound a little off, but I hope you like the solution, and if you like the solution, please subscribe and like my videos. I usually come up with my solutions of my own, which are not in any textbooks or solved question papers, and I try to find the simplest solutions and try to give the most detailed solutions. So please subscribe to my channel and comment below and like. Thank you.